Bismillahirrahmanirrahim. Our today's lesson on reciprocal trigonometrical ratios. This is chapter number 3 from the textbook Maths A2. Secant of an angle, and cot of an angle. We're gonna discuss what are these cosecant, secant, and cot of an angle. Basically, cosecant of an angle, secant of an angle, and cot of an angle. These are the reciprocal relation of basic trigonometric functions. Cosecant of an angle is equal to 1 over sine of an angle A, or we can also write sine of an angle A is equal to 1 over cosecant of an angle A, or we can also write sine of an angle A and cosecant of an angle A, it is equal to 1. Likewise, if we write secant of an angle A, it is equal to 1 over cos of an angle A. Secant of an angle A is reciprocal of cos of an angle A. Similarly, we can write cos of an angle A is equal to 1 over secant of an angle A. Also, if we cross multiply cos of an angle A with secant of an angle A, then it is equal to 1. Likewise, cot of an angle A is equal to 1 over tan of an angle A, or tan of an angle A is equal to 1 over cot of an angle A. And if we multiply on the other side, then we'll get tan of an angle A into cot of an angle A, and answer is equal to 1. If we recall our basic concept from the quadrant, we know this is quadrant number 1, this is quadrant number 2, 3, and 4. These are the 4 quadrants. This is x-axis and the angle is 0. The terminal line between first and second quadrant is of 90 degree. Likewise, 180 degree, 270 degree, and 360 degree. As we know, all positive, sine positive, tan positive, and cos is positive. All positive means sine of angle A will give you positive answer. Cos of an angle A will give you positive answer, and tan of an angle A will give you positive answer. Likewise, in second quadrant, when sine is positive, then cos is negative, tan is negative. Likewise, in third quadrant, when tan is positive, then sine is negative and cos is negative. In fourth quadrant, cos is positive, then as for sine, sine is negative and tan is negative. As we discussed the reciprocal relation, so reciprocal relation will have the same signs of the function. When sine of A is positive, this means that cosecant of an angle A is positive. Secant of an angle A is positive. Tan of an angle A, the reciprocal of tan is cot. So cot is also positive. Similarly, in second quadrant, when sine is positive, its reciprocal cosecant will give you positive answer. Cos is negative, it means secant is negative. Tan is negative, mean cot will give you negative answer. In third quadrant, when tan is positive, its reciprocal relation will give you positive answer. So cot is positive. Sine will give you, as sine is giving you negative answer, then its reciprocal cosecant will also give you negative answer. Reciprocal of cos is secant, so secant will also give you negative answer. The reciprocal of cos is secant. If cos is positive in fourth quadrant, so secant is also positive in fourth quadrant. As sine is negative, then its reciprocal, cosecant will also give you negative answer. The reciprocal of tan is cot, so cot will also give you negative answer. All right. If we consider question from the exercise 3A, this is question number 1, and I've considered 3 examples from the question number 1. Like part number A, if we are looking for the value of an angle with the reciprocal trigonometrical ratios, let's see how do you find the answer of secant of 60. Whenever you have this reciprocal relation, you convert all the reciprocal relations in form of their original function. Like reciprocal of secant is cos, so you write it 1 over cos 60. Cos 60 is equal to 1 by 2, so this is your answer. Likewise, if it is cosecant of 45, we can write cosecant of 45 is equal to 1 over 45. Sin 45 is equal to 1 over under root 2. So we'll get finally under root 2. In C part, cot of angle 120 is equal to 1 over tan of 120. Tan of 120 is equal to minus 1 over under root 3. So this would be your answer. So in exercise 3A, question number 1, we will find the values of these reciprocal trigonometrical ratios like secant of 60. So whenever you have reciprocal relation with the angle, so you always have to convert these reciprocal relations into their functions. Like secant of 60 is basically equal to 1 over cos 60. You use the calculator, you'll get the answer 1 over 1 over 2. And when you flip it, you'll get 2. Likewise, cosecant of 45 is equal to 1 over 45. By using the calculator, you'll get the answer. When you flip it, you'll get under root 2. Cot of 120 is equal to 1 over tan 120, and tan 120. Calculator will give us this answer. So this is your final answer. All the angles were in degrees. If we have the angles in radians, the procedure would be same. In question number 2, we have given reciprocal trigonometrical function with the angles in radians. Procedure is again the same. Whenever cosecant of pi by 6 will have, we'll write it 1 over sine pi by 6. Tan pi by 6 sine pi by 6 is 1 over 2. We'll get this answer. Similarly, we can find part B and C. Next concept is reciprocal trigonometrical identities. So far, we have learned about sine square of an angle A plus cos square of an angle A is equal to 1. From this identity, we can further find sine square of A is equal to 1 minus cos square of A. And cos square of A is equal to 1 minus sine square of A. So this is what we have learned in our previous class. The next trigonometrical identity which we'll discuss is secant square of A minus tan square of A is equal to 1. We can further find secant square of A is equal to 1 plus tan square of A, or if we want to find tan square of A, we find it secant square of A minus 1. Third case is cosecant square of A minus cot square of A, which is equal to 1. Cosecant square of A is equal to 1 plus cot square of A. And if we want to find cot square of A as a subject, we'll get cosecant square of A minus 1. So these are the further identities which will apply in the coming questions. This is question number 8 from the same exercise. Consider part B, and in this B part, we have trigonometrical reciprocal ratios involving cosecant and cot. As we all know that whenever we have the equation and we are solving it, we will find the values of the angles. And we have to write the equation in one function, as we have cosecant square and cot. So we'll try to convert this equation into one function. Either it would be in the form of cosecant or in the form of cot. But if we recall the identities, all the identities are in the form of the square. Let's see. So these are the identities, and you can find these identities on your formula sheet. So we'll convert cosecant square by using the identity. The question is in the form of reciprocal functions, and we need to rewrite the equation by using the identities in one trigonometric function. Like cosecant square can be converted by using the identity in the form of cot. It is equal to 1 plus cot square of A, which is equal to 13 minus cot of theta, and 3 plus 3 cot square of theta is equal to 13 minus cot of theta. 3 cot square theta plus cot of theta and minus 10. You can use quadratic formula, or you can break the middle term to write the factors. Now we have cot of theta is equal to minus 2 and 3 cot of theta is equal to 5. We can write it cot of theta is equal to 5 over 3. As we learned that whenever we have reciprocal functions, we convert them into basic trigonometric function. Cot of theta is equal to 1 over tan of theta. It is equal to minus 2 over 1. When you flip the fraction, you'll get this value, minus 1 over 2. Here we use the calculator to get the answer. Let me use the calculator. Theta is equal to minus 26.6 degree. As angle is negative, so we measure the angle in clockwise direction from the positive x-axis. Would be this angle is acute angle, so we call it as a basic angle, and we are dealing with the tan. Tan is positive in the first and second, and negative in second and fourth. As our first angle is lying in the fourth quadrant, so our second option would be in the second quadrant. As domain is lying between 0 to 360. Let's see the domain again. Less or equal to this one. Our angle would be, one angle is this one, other angle would be this one. Now we'll find the other values. Cot would be written in the form of tan of an angle theta, which is equal to 5 by 3. When you flip the fraction, it becomes 3 over 5. As we are looking for the angle, by using the calculator, we'll get one of the answer. Answer is 30.96, which is equal to 31 degree. Angle is positive. When we plot this angle into the quadrants, it is acute angle, positive angle, and it is acute, so it would lie in first quadrant. Angle is 31 degree. Tan is positive in third quadrant. So other angle would be in the third quadrant. As domain value is lying between 0 to 360 and 0 is included, 360 is included. First of the angle would be 31 and other angle is in the third quadrant. How do we write it? First answer is 31 and second answer is 180 plus 31. Answer is 211. Finally, the answers are 153.4. So finally, when we write the answers, 31, 153.4, 211, and 333.4. So these are the answers. Likewise, if I consider another example, this is E part from the question number 8. This equation involves tan and secant. If we write the identities, we'll see that which identity we are going to apply. Identities related with sine, cos, and their reciprocal relations are in the form of square. Okay, so let me show you the identity from which we'll get the value of tan square. If we use the value of tan square, we write it as secant square of a minus 1 plus 3 secant of an angle theta. Let me correct it. It is theta. When you rearrange it, it is a quadratic equation in the form of secant theta. Use the quadratic formula. Secant of theta is equal to minus 3 plus minus 3 square is 9, 4, A and C. Secant of an angle theta is equal to 1 over cos. So when you flip the fraction, it would be this one. By using the calculator, we can get the answers. Shift cos inverse fraction 2 over minus 3 plus root of 5. So it's not possible because we are getting the answer in form of iota. If still you have problem in understanding this, so let me convert this value into decimals. It is 2 over minus 3 and plus root of 5. So this is what I'm getting. It is equal to minus 2.618. So answer will not be possible because cos of an angle theta always lies between 1 and minus 1. Okay. The other equation which we are going to solve is secant of theta is equal to minus 3 plus under root 5 over 2. Using the concept of reciprocal, secant would be written in the form of 1 over cos. Now we flip the fraction here. Now it's better if we convert the fraction into the decimals. Let me correct it. We need to use negative sign here. This is negative sign. This is negative sign. Okay. Whenever we are finding the other factor, it is secant of theta is minus 3 minus under root 5. And secant would be converted into 1 over cos by using the reciprocal concept. Cos of theta, when you flip the fraction, you'll get this value. Now I'm finding the decimal of this fraction. And its answer is 0.38196. Shift cos inverse of the answer. So theta is equal to 112.5 degree. When you show this angle into the second quadrant, here you need to find the basic angle. Basic angle is an acute angle. So subtract your angle from 180, you'll get 67.5. So this is the basic angle. You can see the value here is negative. So your cos would lie in the second and third quadrant. In second quadrant, we have shown the angle, but when we are looking for the angle in the third quadrant, we need to show the basic angle, and then we'll find the angle from the positive x-axis, because x is greater or equal to 0, less or equal to 360. So in one complete round, we have these two options of the angles, and the answer would be 112.5 and other is equal to. So finally, we'll have 247.5. Our answers would be 112.5 and 247.5. All right. So this is it. In this lesson, we learned what are the reciprocal relations and how do we find the angles of the reciprocal relations, and how could we find solution of the equations involving the reciprocal functions. In next video, inshallah, we'll learn how to use the identities to prove the trigonometrical identities, and especially such identities will involve reciprocal trigonometrical function. Okay, so take care.